Thank you for introduction. Good afternoon. I'm going to present our work towards a self-sustained moisture and temperature monitoring system using soil energy. First, I will talk about our motivation and the advantage of using soil energy in environmental monitoring. Then, I will present the design and the major results of temperature and the moisture sensors using soil energy. Finally, I will summarize the talk. Severe weather change and global warming are two critical environment issues around the world. Occurrence of flood, landslides, typhoons, and tsunami increased dramatically in these years. For example, in 1970 to 1999, the severe typhoons hit my country approximately every 3 years. But after 2000, the severe typhoons hit my country every year. The natural disasters usually result in a large amount of losses in the properties and casualties. Therefore, the environmental monitoring system is necessary. They can provide long-term monitoring and fast alarm when the disasters occur. And we'll face some challenges in developing the environmental monitoring. The environmental monitoring requires low cost of measurement instruments for widespread deployment, long distance and reliable communication for real-time and fast alarm, reliable and sufficient energy source to avoid frequent battery replacement. Recently, a hot research topic of wireless sensor networks can provide a potential solution for the low-cost implementation of environmental monitoring. The sensors are placed around the rivers or the mountains where the disasters may occur. And these sensors report the condition of the environment to the central station for analysis. By this way, we can save the cost in developing the environmental monitoring. However, the energy source is still a critical issue in developing the sensor network. Sustainable energy sources play an important role in long-term monitoring. Here are a comparison of some widely used energy sources in environmental monitoring. The batteries have good energy capability per area and low environment restrictions, but the cost and the resulting pollutions are high. The solar energy is the green energy, but it is limited by the weather and the environment. And some researchers use tree power to supply the subsensory system. The tree power is low cost and low pollution, but the critical limitation of the tree power is that the amount of energy produced by the tree is less than 1 microwatt. Thus, the tree power is not an alternative energy source for environmental monitoring, but an auxiliary to extend the battery's lifespan. So we try to find some other energy source for environmental monitoring. The Earth is a large capability energy cell. The figure shows that the soil absorbs the solar energy for less than billion years, so we can see as a large battery. The advantage of the soil energy is that it is a kind of renewable and green energy, and this energy is produced by biochemical reactions. Since the soil is portable and widespread in the world, so it is very suitable for the use in environmental monitoring. The figure shows the concept diagram of the soil cell operation. The soil cell can be viewed as a microbial cell, which use inexpensive and self-renewable bacteria as the catalyst. It can be an alternative energy source to remedy the environment and energy endeavors. The soil acts as the nutrient-rich analytic media and the proton exchange membrane to transfer the electrons. The bacteria cohere on analytic electrodes and convert the chemical energy to the electrical energy. The electrons produced by the bacteria can flow from the anode electrodes to the cathode electrode and can be used to power up the electronic systems. The electrode materials are key for the charge transfer rate and increasing potential difference between the electrodes. The electrode material need to have strong thermodynamic and kinetic responses to ensure that the interface molecular reactions are fast enough to release the oxygen electrons. So we tested the different electrode materials, and we find the soil cell with zinc carbon electrodes can provide maximum open loop voltage about 1.1 volts. And we first fabricated a 36.5 cubic centimeter soil cell using zinc carbon electrodes. Since the soil cells have internal resistance, so its output power may vary with the load impedance. The measured result shows that the maximum output power of fabricated soil cell is about 75 microwatts, occurring at a load resistance of 2 kilo-ohm. This energy is much larger than the tree power, and is sufficient to operate the sensor system with simple power saving scheme. We first demonstrate the temperature and the moisture sensor system using solid cell energy. The proposed system consists of DC to DC converters, temperature and moisture sensors, microcontroller, and a LCD. The DC to DC converter is used to boost up the voltage from the soil cell to operate the sensor system. And the sensors are used to monitor the temperature and the moisture of environment. An LCD is used to display the data from the sensors. We also use the duty cycle technique to reduce the average power consumption. And in the DC to DC converter design, we chose the 4-phase non-overlap clock signals architecture. The schematic and the clock signals are shown here. M1 to M4 are passing transistors, which use pump the charge flowing from the input to the output. And compared to the conventional architecture, we added the MA1 to MA4 transistors, which used to boost up the voltage drop across the passing transistors, reduce the conductance losses, and improve the power efficiency. The voltage is boosted up stage by stage through the capacitive coupling. The chip is fabricated in 90 nanometer CMOS process, and the chip can be powered solely from the soil cell to operate the system. The 4-stage DC to DC converter can provide 2.5 times voltage conversion. The conversion efficiency is about 60%. The sensor system built with commercial sensors, which is controlled by microcontroller. The system monitors the environmental temperature and the moisture every 80 seconds. The figure shows the major result of temperature and moisture in Hsieh, Taiwan for 15 hours. I would like to briefly summarize my talk here. The soil energy can be an alternative energy source for environmental monitoring, since it is easily accessible and renewable and friendly to the environment. We first demonstrate a self-sustained moisture and temperature monitoring system using soil energy solid. In the future, The system can be integrated with wireless communication system for further use in the remote environmental monitoring. Thank you for your attention.